Hi guys, welcome back to my channel. This is Rithvik and today we are going to solve the problems from the chapter Complex Numbers. So let's dive in. The first problem, 2 plus 3i by i. So the way to get the solution for this problem is breaking this term into two terms. How? 2 by I plus 3i by I. How? Because the denominator is same, so we can easily break into two terms and we easily obtain the answer. So here we can cancel I and I, so we'll remain with 2i by 2 by I plus 3. So in the previous video we have discussed how to eliminate the iota in denominator form by multiplying on both the sides like numerator and denominator. So 2 by I into I by I. Here I am not changing the value, I am just rationalizing it. Plus 3, which is 2i by I square. 2i by I square. So we know the value of I square, so we can directly substitute the value like minus 2i plus 3. This is our answer. So if you understood the concept with clarity, you can do the second sum. Please pause the video and do the second sum. If not, no worry at all, I'll explain you. So coming to the second problem, this is the easy way to solve this is separating the minus sign from the real quantity like this. And we have to place I in place of root minus 1. So I into 3 into I into 5. So 15 I square. We know the value of I, so we can directly substitute it. So the answer which we get is minus 15. If you got the correct answer by doing it your own, put a tick. If not, no worries, correct the mistake which you have done. So coming to the third question, express 2 minus 3i whole cube in the form of a plus ib. The only thing which we have to apply in this third question is an identity. So what is that identity? A minus b whole cube. So a minus b whole cube. Why should we use only a minus b whole cube? Because here 2 minus 3i ka whole cube. So here 2 acts like a and 3i acts like b. So there is cube. So this is why we have to use a minus b whole cube. So what's the value of a minus b whole cube? The value of a minus b whole cube is a cube minus 3a square b plus 3ab square minus b cube. So next one is simple. Just to substitute the values in place of a and b. Like let us assume that a as 2 and b as 3i. So a cube, 2 cube plus minus 3a square b minus 3 into 2 square into 3i plus 3ab square plus 3 into a 2 into 3i whole square. 3i whole square. 3i whole square. So the next one is minus 3i cube according to the formula. So we just have to simplify it. That is 8, 2 cube is 8, minus 3 into, the value of this is 4. The value of this is 4. So 3 into 4 into 3, which is 12 3s are 36 plus 36 I. Sorry, this is minus 8 minus 36 I plus 3 into 2 into 9, because 3 square. 3 into 2, which is 6. 6 into 9, which is 54. And here I square, which is minus 1. Multiplication of minus 1. And coming to the last term, which is b cube minus b cube, which is minus 27 I cube. So here we have to evaluate the value, which is 8 minus 36i. Leave 36i as it is, and minus 54 minus 27i. Do you remember, plus 27i? Do you remember the value of I cube? It is minus I. So I'm doing it here. Minus 27 into minus I, the value of I cube, minus I. So minus will get cancelled and we get positive 27i. So just to simplify it further, so we get 8 minus 54 and 36 minus 36 plus 27 is minus 9i, and the solution for this is minus 46 minus 9i. So simply we can take out the minus common and I. So this is the answer. If you have done this problem on your own, that means you have understood the entire I chapter. That means anything related to I, you can do it on your own if you have done this problem. So coming to the fourth problem, I power 10 plus I power 11 plus I power 12 plus I power 13. So in the last class, I haven't explained you one thing, that I power 4 k, anything, I power 4 into k, where k is a natural number, is 1. So I power 4k is 1. Remember this point. So this is the small concept which we have to use in the fourth sum. So how can we write it in terms of 4? Like I power 4 into 2 plus 2. Can we write? Because 4 2s are 8. 8 plus 2 is 10. Plus I power 4 into 2 plus 3. Because 4 into 2 is 8 and 8 plus 3 is 11, plus I power 12, which is 4 into 3, plus I power 13, which is 4 into 3 plus 1. So here we have to use a small concept from exponents and powers. What is it? That is a power m plus n equal to a power m into a power n. This is the small concept which we have to use in this problem. So Here 4 into k. I told you that any number like I power 4k, where k is a natural number, any number which is any power of I which is a multiple of 4 is 1. So I power 4 into 2. So I can write it as I power 4 into 2 into I square, because I power m plus I power n is I power m into n. I power m into I power n. Sorry, a. So this is I square. The value of I power 4 into 2 is 1. This is I square. Coming to the next one, I power 4 into 2 into I cube. The value of this thing is 1, and I cube is, we have to substitute the formula. Then the next term, I power 4 into 3. The whole term is 1, and the other thing, the last term is I power 4 into 3 into I power 1, and this term is 1. So the circle terms are 1. I'm stressing out this point because this property of I is used in many problems. This is very important, which is, what is it? Any power of I which is multiple of 4 is 1. So we can write the terms as they are. So I square, the value which we know the value of I square, which is minus 1. I cube is minus I. This one is plus 1, and again plus I. So minus I plus I gets cancelled, plus 1 minus 1 gets cancelled. So we obtain 0. 0 is the answer for fourth one. This is a good question. So coming to the fifth question, this is also there is a property called modulus. There is a separate concept of modulus of complex number. So I haven't explained you. Now I am explaining you. As the sum came, any property, when they ask us the modulus of a complex number in the form, generally complex number are in the form of a plus ib. So if they ask us modulus of a complex number, the formula is a square plus b square, root of a square plus b square. So this is the simple concept and very short. You would understand it better if we do the example. The question is 2 plus 3i, mod of 2 plus 3i. The formula is square root of a square plus b square. Here a is 2, that means 2 square plus 3 square ka square root. So square root of 2 square, which is 4, plus square root of 3 square, square of 3, which is 9. When we add them, we obtain root 13. So this is the final answer. So this is how we solve modulus of any complex number. So the next questions are 1 plus I into 1 plus I square into 1 plus I cube into 1 plus I power 4. How can we solve this? We cannot solve this because 1 plus I, 1 plus root minus 1, we don't know the value. 1 plus root minus, so 1 plus I cube is minus I, we can't write the value. 1 plus I power 4, which is actually 2, we just know the fourth term. But when we see the second term, it is 1 plus I square. This is I square, 1 plus I square. So the value of I square is minus 1. The value of I square is minus 1. Plus 1. So when we do the total of the sum, we obtain 0. We obtain 0, no? So 0 multiplied to any other term is 0. 0 divided by any other term is 0. So the final answer is 0. So coming to the 7th question, they gave us the z value and they were asking about the value of z square. They are asking the value of z square. So they gave us the value of z. They gave us the value of z. So easily we can do directly 7 minus root 3 I whole square. So the simple thing which we are applying here is a minus b whole square. A minus b whole square. So here a is 7 and b is root 3i. Don't forget I. This is the most important member in the chapter complex numbers. So z square is equal to 7 minus root 3i whole square. So this is a and this is b. So a square, the formula is a square minus 2ab plus b square. So a square, that means 7 square means 49 plus minus 2ab minus 2ab, which is 2 into 7 into root 3i plus b square 3i square. So which is 3i square. So we have to do the further process to simplify to get the solution. So 49 minus 2 into 7 into root 3i plus, instead of writing plus here, we know the value of I square. So we can directly write minus 3. So the next process will continue in the same way. 49 minus 2 into 7, 14, which is 2 into 7, 14 root 3i minus 3. This is the solution. This is the answer for the 7th one. Coming to the 8th question, the value of I power minus 999 is, so I don't like negative powers, so I first wanted to convert this into positive power, so I like positivity, 999. The second step which you are supposed to do is to write the power in multiplicative terms of 4, like I power 4 into 249 plus 3, because 4 into 249 is 996 and we are still left out with 3. Keep the 3 here. So 1 by I power this one is 1, but we are still left with I cube because plus 3 is there, the power with plus 3, so we are left with I cube. So now how can we do the problem? Do the same thing, multiply and divide by I. So I by I power 4. The value of I power 4 is very easy, which is 1. I by 1 is the answer. So we have been doing sums based on I. Now we are going to do one tough question based on cube roots of unity. If you do that one sum on your own, you have got the complete chapter. So let's see that problem. We have been doing many sums based on iota. So let us do something special. We are now going to solve problem based on omega. Do you remember omega is the cube root of unity? So in this problem, we'll cover most of the properties of omega. Let's begin. The value of sine omega power 10 plus omega power 23 into pi minus pi by 4. So in primary classes we have learnt a property called BODMAS. We have to first simplify the value which is in the brackets. That is omega power 10 plus omega power 23. How can we simplify this brackets? We have discussed one property based on omega, that is omega power 3k plus 1 is omega. How can we relate this property to this? We can, because omega power 3 into 3 plus 1, which is omega 3 into 3, which is 9. 9 plus 1 is 10. So we can relate this property to omega power 10. Then there should be something where we have to relate this even. So this is omega power 3k plus 2, which is omega square. How? Omega power 3 into 7 plus 2. 3 sevens is 21. 21 plus 2 is 23. So we can relate this two properties with this problem. So this becomes sine omega plus omega square. Omega square. Pi minus pi by 4. Omega square. So we need the value of omega plus omega square. How? We can use another property which is 1 plus omega square. This is 0. So we need the value of omega plus omega square. What should we do to get omega plus omega square? We have to transpose this 1 to RHS. How? Omega plus omega square is minus 1. So this way we got the value of omega plus omega square. So directly we can substitute the value. Omega plus omega square is minus 1 into pi minus pi by 4. So multiply this minus sign with pi, which becomes minus pi by 1 minus pi by 4. So do the further simplification where we get minus 5 pi by 4. The value of pi is 180. This is the value which we are going to use in this type of problems based on degrees. But based on meters and based on measurements, we use 22 by 7. But we are not going to use this value of pi in this particular problem, because this problem is related to degrees. This problem is related to meters. So this is why we have to opt this value of pi. Okay, you understand? So we got the value of pi. Simple way. Sine minus 5 into 180 by 4. 4 1s are 4 45s are sine 45 into 5, which is minus 225. So we have got the answer, but we still have to simplify this further. How? This is the degree, the value of the angle is in minus, is in negative. So we have a property of sine, which is sine minus x is minus sine x. Value of sine minus x is minus sine x. So the value of this is minus sine 225. There is another problem. This 225 is not in first or second quadrant. This falls under third quadrant only where tan and cot are positive and remaining all trigonometric ratios are negative. So how are we gonna simplify this? We can break this angle into minus sine plus 180 plus 45. 180 plus 45 is none other than 225. What is the next step? So this 45 is going to be the reference angle. Reference angle. As I told that the value of sine 225 falls under third quadrant, and where we have to put minus sign when we use the reference angle. So the reference angle is sine 45 degrees. So what are we going to do? Minus of minus sine 45 degrees. I'll explain you again. See, 225 degrees falls under third quadrant. In third quadrant only tan and cot, only these two trigonometric ratios are positive. Remaining trigonometric ratios like sine, cos, cosecant, secant, everything becomes negative. So I wanted to break this angle into two parts like 180 plus 45 degrees. So where 45 degrees becomes the reference angle, and we use 45 degrees and put the minus sign as it falls under third quadrant. So the answer which we get is sine 45 degrees. The value of sine 45 degrees is 1 by root 2. So this is the answer which we got. So hope you enjoyed the video. If yes, please hit the like button, subscribe to my channel, and tata and bye bye everyone.